Let X be a square matrix. Consider the following statements on X. Statement 1, X is invertible. Statement 2, determinant of X is non-zero. Which of the following is true? 4 statements are given regarding which of these implies the other. Now this is a very straightforward question coming from linear algebra. When you learn linear algebra, you will see that if X is invertible, the determinant of X will be non-zero, and if the determinant of X is non-zero, X will always be invertible. These two are equivalent statements. I will give the proof of it as well. Let us take statement 1, X is invertible, which will imply that X inverse exists, and X inverse can be given by adjoint of X by determinant of X. That is the formula for X inverse. Now if this exists, which will mean that this determinant part will be non-zero. If this was non-zero, it will be something divided by a zero number which will be not defined. But since this is defined, we can say this part, the denominator is non-zero, which means determinant of X is non-zero. That is nothing but statement 2. Now if you look at statement 2, it says that determinant of X equal to non-zero, which means we can form the matrix adjoint of X by determinant of X. Adjoint of X matrix exists for every matrix. We can be sure that this matrix exists divided by this determinant value which is non-zero, which will give us inverse of the matrix, X inverse. This is a formula for inverse of the matrix. Now we see that X inverse exists, or we can write X is invertible, which is nothing but statement 1. So we see that from each of these statements we can conclude the other statement, which means both of these are equivalent statement. That is option C.